Good evening everyone. Today we are going to do the daily Leetcode challenge of 30 January 2023. That is question number 1137 and Tribonacci number. It is so much similar to Fibonacci number. If you have done Fibonacci number, this question is a piece of cake for you. In this video, I will be discussing multiple approaches for the question. So what is a Tribonacci sequence? Let's understand that. It is a sequence which comprises of sum of previous three elements. In Fibonacci, it was sum of previous two elements, but in Tribonacci, it is sum of previous three elements. Okay, and initial elements of the Tribonacci sequence they have given you, that is 0, 1 and 1. So without further delay, let's move on to the first example. In the first example, we are given n is equal to 4. So to get T4, we need to know T3. Okay, plus T2 plus T1. That is what we have to do. And for T3, we should know T2 plus T1 plus T0. And what is T0? T0 is 0, T1 is 1 and T2 is 1. So T3 becomes 2. So for T4, how can we get the answer? T4 will become 2 plus 1 plus 1. That is 4. So it is our answer. So if you see what we are doing, so there are two approaches. First is by recursion, another is by dynamic programming, and third is similar to dynamic programming in that we also use a loop and we are storing value along with the loop and we are updating those values. So we will see them one by one. So let's start with the most common approach, that is recursion. The first approach is recursion. So in recursion, what do we do? In recursion we take leap of faith. That means we trust on recursion and we just tried the code and we believe that recursion will do it. What it means is to get T3 I need T2 plus T1 plus T0, and to get T4 what I need T3 plus T2 plus T1, and to get T5 I need T4 plus T3 plus T2. So if I know the n function, if I want to know the n function, I need n minus 1 plus n minus 2 plus n minus 3, and it will be a function f, recursive call of f, to get the fn value. That is what we have to do in recursion. So let's move on to the coding section and try to code it. So to code this, what we will do, we will initialize if n is less than equal to 1, we will return n. What it means is, if n is equal to 0, what we have to return? 0. If n is 1, what we have to return? We have to return 1. If n is 2, we have to return 1 as well. So for 2, we will write it again. Okay. Return n. If n is equal to 2, we return 1. We can also write return like this. And after that, we have to call a recursive call, that is return Tribonacci, that is n minus 1 plus Tribonacci n minus 2 plus Tribonacci n minus 3. So this is your answer, which means that if I have to get T4, T3, T2 and T1 are being substituted, and for getting T3, T2, T1 and T0 are substituted in the recursive call. That's it, it is accepted. So let's just submit it and check whether it is accepted or not. Ideally it should not be accepted because it will cause TLE, because recursion is calling it so many times. Yes or no? So yes, 36 out of 39 cases pass. So it is not passing for 3 cases. So those cases will be covered by dynamic programming or by using the loop approach. So let's move on to the second approach. So in the second approach, what we have to do, we have to apply recursion. So instead of calling the function again and again, calling the function again and again and again, what if we store the value? What I mean is, if I have to get the value for n is equal to 4, what I will do, I will store the value for n equal to 3, and for 0 and 1 and 2 we already know the value, n is equal to 0 0, 1, 1, and 2 is also 1. So for getting 3, what I will do, I will already store these values and then I will return it. And for getting 3, I need T2 plus T1 plus T0, and I already know this value. And for getting 4, T4, I need T3 plus T2 plus T1, and I also know these values. So I will simply just substitute the values and I will store the values. So how can I store? There are two ways. As we are discussing with the DP method, dynamic programming method, what we will do, we will create a vector of n plus 3 size, and we will store all the values in a single loop of on. We will run through the loop and we will store the values in the vector and we will use them when required. Okay, so what I mean by that if we initialize our initial value, that is 0 value to 0, in first value to 1, and second value to 1 as well. If we initialize them initially and we will run a loop for I to n, we will run a single loop, and inside the loop we are updating our values, and we are updating our values by using the same function dp I minus 1 plus I minus 2 plus dp I minus 3. So this way we are updating the values, and if there is 3, T2, T1 and T0 values will be put in this and we will get our answer. And if there is 4, T3 will be substituted here. And finally we will write return, we will return our dp n, whatever the number is given to us. So it will run in on complexity. So the complexity is reduced, but we are using a space of on plus 3, which is equivalent to on space. So this is what is happening. So let's try to code this and see how it is working and whether it is accepted or not. So for dynamic programming approach, we will create a vector dp of n plus 3 size because and initialize every value with 0. After that, we will initialize our 0 to 0, first value to 1, and second value to second. We are making an array and inside that we are storing these values. After that, what I told you, we will run a loop. From where will we start our loop? We will start our loop by third value because 0, 1, 2 values you have already given. Now after that you will run the loop through till I is less than equal to n. Whatever the value of n is given to us, we will run the loop till that and we will return our answer. And our that value of I from third will be dp I minus 1 plus dp I minus 2 plus dp I minus 3. And when the loop is done, we are having all the values we require for returning the value of this n. We will finally return dp n. So this should work and this should be acceptable as well. Let's run this. There's an issue. What's the issue? We are getting 6 as an answer because we have written dp2 is equal to 2. It should be 1. So now it is working. Yeah, let's submit it. So yeah, it is done in on time complexity. So this was the second method. And now moving on to the final third method, which will be by using a loop and not using dynamic programming directly. So in the third method, what do we actually do is, instead of storing them in a vector, we will store them while iterating. What I mean is, we will create some variables a, b, c and d. Okay. Suppose if our value is a will be initialized with 0, if b will be initialized with 1, and c will be initialized with 1 as well. That represents 0, 1 and 2. T2, T1 and T0. And D represents our n number. Suppose if we have to get for 3, T3 will become A plus B plus C. And when we update this T3 for the next values, let's say our n was 4. So we start from, we will make a count variable. Count variable, let's say, is 3. And when we start the loop, our D will get updated. count is 3 and 3 is less than 4, D will get updated to A plus B plus C. When this is done, we will change our A to B, B to C, and C to D. And we will increment our count plus plus. So now count value becomes 4. 4 is less than is equal to 4. So loop will run. So for T4 value, we have A plus B plus C. And now A plus B plus C values are updated. Yes or no? This is what you have to do. This is how you can do it. So initially it was 0 plus 1 plus 1. After the loop, it will become 1. It will become 1 and it will become 2. So it will become 1 plus 1 plus 2. So T4 will become 4. And then we again increment our count. Count becomes 5. 5 less than 4 is not true. So we exit our loop and we will finally return our D. So it is similar to dynamic programming memorization, that we are memorizing or storing the value somewhere. But it is happening with loop and we are not directly using dynamic programming in this question. So to code this, what we can do, we can write int A is equal to 0, B is equal to 1, C is equal to 1, and D will be a variable, and we need a counter which will start from 3. If our n is less than is equal to 1, we will return n. If our n is equal to 2, we will return 1. But if it is not the case, we will run a loop while our count is less than n. And in the while loop, what we will write, D is equal to A plus B plus C, and count is initially with 3. So we are exactly storing the value somehow, and we are updating them as well. A is equal to B, B is equal to C, and C is equal to D. And when this while loop exits, we will get our answer, that is return D. So let's run and check whether it is working or not. So it is giving error because we have not incremented the value of count. Also, we haven't written it as count less than or equal to n, because we have to get the value of n. So we have to consider the case when it is equal to n. And now it should work. So yeah, it is running for cases. Let's submit it. And yeah, it is also accepted. So the time complexity in this case is also O of n, but the space complexity is reduced from O of n to O of 1, that is constant space complexity. So this was the most optimal approach. I hope you liked the video. Please understand all the approaches. If you have any doubt, do let me know in the comment section. Thank you so much for watching. Please like, share and subscribe. Bye bye.